Okay, so just a reminder, the first assignment is due today, and then we're going to take it up on Monday. And then I believe the test is scheduled for Friday, and that'll of course just be on chapter 1. Yeah, and for the test, I'll just email it to you in the beginning of class, and I'll activate Dropbox, and then everyone just does the test and submits it on Dropbox within like an hour and 10 minutes. And that's how we'll do that. What else? Does anyone have any questions about anything? Okay, everyone seems good. Buddy's good too. Okay, so today I promised that we would do a review. So let's start on that. And if there's any particular topics or questions that anyone wants to go over, feel free to ask, because I'm just going to kind of just generally go over everything. I think we'll focus a little more on the more difficult stuff, like adding fractions and stuff. Okay, still recording, good. Let's share screen. And these questions, I'm just going to do these based off of the additional material that's posted online. So all of these are available to you. And I recommend that you use them because, yeah, they're very similar to what will be on the test. Okay, so the first thing we did was reducing fractions to lowest terms. Now, of course, for that, we had to learn about the concept of factors, which are numbers that we multiply together to get other numbers. So basically, any number can be broken down into its factors. And then if you keep going and going, you'll break it down into its prime factors. So you do have to at least kind of be aware of factors in order to reduce a fraction to lowest terms. So let's do the first one. 24 out of 36. So in this case, we want to figure out what divides evenly into the top, what divides evenly into the bottom, and what, of course, is the largest number that works for that. Oh, we got a chat. Let's see. Someone said 6. Let's see, 6. 6 would work, but I think there's a higher one. Yes, exactly. So 12 would be the highest one. You could use 6, but then you'd have to keep going and you'd have to take another 2 out of it. So you always want to go with the largest one. So you just divide by 12, divide by 12, and you get 2 over 3. So yeah, that is reducing the lowest terms. We've already kind of done a bunch of these, so I won't do too many more. Let me just see if there's any interesting ones. This one's interesting, 19 over 38. So this one's interesting because 19 is a prime number. Remember, a prime number is something that's only divisible by 1 and itself. It doesn't have any meaningful factors. So prime numbers are like 7, 13, 17, 19, 23, and then it keeps going forever. And I think I mentioned this before, but if you can map out how the prime numbers are distributed in the number line, you win $1 million. That's one of the Millennium Prize problems. It's something called the Riemann conjecture. So anyways, 19 is prime. So your only option in this case is to try to just take a 19 out of this fraction. And luckily the bottom is divisible by 19. So divide by 19 on the top and the bottom, and you get 1 over 2. Okay, so any other interesting ones? What do you think, buddy? Okay, so let's go to the next thing, which was converting from improper fractions to, or sorry, converting from mixed numbers to improper fractions. Like I said, we'll just do kind of 1 or 2 of each, and then we'll focus on the more difficult ones. So the first one is, let's do 2 and 1 over 3. So remember, the formula for this was this number times this number plus that number, and then you keep the bottom number the same. So 2 times 3 plus 1, that's what you'll get on top. And then on the bottom, you get 3. So in this case, you get 7 over 3. Is that right? Yes. Okay. So in general, if you wanted kind of a formula for that, it would be A and B over C is equal to A times C plus B, and then it's over C. So you do have to remember to put it in like fraction form, because a lot of people will just write the answer as 7 and they'll forget to put 7 over 3. And of course, 7 is not the same as 2 and a third. So you got to remember the numerator and the denominator as well. So that was converting. And then of course, we have the option of converting in the other direction. So let's try to find a couple questions for those. We have that one, but that one looks really familiar. Let's do 26 over 3. 26 over 3. So for this one's a little more difficult, but not by much. So you look at 3 and you count how many whole times does 3 go into 26. So it goes in, how many times? If it went up to 27, that would be too much. So it can go up to 24, and that would be 8 times. So it goes in 8 times, and that is always your whole number. And that brings you up to 24. And then you just count how many numbers are left over. So 24, 25, 26, 2 numbers are left over. So 8 and 2 over 3. So that's always what you do for those. For the whole number, it's always how many whole times does it go in to the top number. A lot of people will mistakenly use 24 as the whole number, which is understandable because that's what it goes up to, but you only just use the number of times it goes in to the top number. And then this is always the remainder, and this is always your original denominator. So that is that one. What else? So yeah, not much else to say about those. Next one is multiplying and dividing fractions. So we'll just briefly go through these because these ones are kind of surprisingly straightforward. Hopefully everyone remembers the rule for multiplying fractions. If you can't remember it, you can pretty much just deduce it because it's the simplest possible rule. It's just multiply the top numbers and multiply the bottom numbers, and that's all you have to do. So let's look at 2 over 6 times 4 over 7. So for this particular one, there's 2 ways of doing it. You could just, multiply the top numbers, multiply the bottom numbers, and then the answer will be reducible. So let's do it that way. And then we'll do it with cancellation as well. Okay, so 2 times 4 is 8. 6 times 7 is, I'm so bad with the 6s and the 7s, but I think that's 42. Yes, 42. And then in this case, we can, of course, reduce. We can at least take a 2 out because these are both even numbers. But I think we could also take, what's the largest thing we could take out of this? It looks like just a 2. Can we take a 4 out? Is 42 divisible by 4? No, I don't think so. Okay, so we can only take a 2 out of here. So divide by 2, and you get 4 over 21. And I would double check that to make sure that it's reducible. So 21 only has factors 3 and 7, and 4 has none of those factors. So that's fully reduced right there. But like I said, you could have used cancellation originally, which I personally like using because all the factors are already exposed. And this one's actually interesting because one of the fractions is reducible itself. So you could reduce it before you even continue with the question. You got a 2 over 6, which is, like I said, you can reduce it. You could take a 2 out of there. So divide by 2, divide by 2. And for this, you would just get a 1 on top. So I'm not going to bother to write that. In this, you would get a 3. And then you have a 4 on top. And on the bottom, you have a 3 times 7, which is 21. So either way, you will get the exact same answer. And you'll end up taking out the exact same fraction or the exact same factor, regardless of how you do it. Someone just asked, is the entire session review? Yes. Usually I'll try to do at least one class of review before a test, although the test is not for another week. Let's see if there's any other interesting ones. Let's check the chat. Someone's asking if it's optional. Well, I mean, anything in life is optional. It's up to you if you want to. If you think you're good with the material, then that's fine. If you want to work on something else, let me just make sure I have the attendance for everyone. Hold on, stop sharing. Let's see. No worries, no worries. Let me just, since I'm doing the attendance anyways. We got this person, we got this person. We got that person. Geez, almost everyone is here. That's impressive for a Friday class. Today's Friday, right? Yes. Okay. It feels like Saturday for some reason. Okay, so let's keep going. So yeah, if you're good with all the material, then you're free to head off the stream. But I'd encourage everyone to stay. Let's see here, maybe for extra appeal, I'll put the camera on, and there's Buddy. He's still sitting on my shoulder, just chilling and listening to the lesson. Hi everyone. Okay. Actually, well, you can't really see him, so I'm going to turn the camera off anyways. He's pretty much hiding behind me. Okay, so let's keep going. Share screen. Let's get rid of this. So where were we? Oh, so we were doing some multiplying fractions. Let's just see if there's any other interesting examples that we can do. Something involving cancellation. Oh, there's some specific ones for cancellation as well. Let's find, oh, this one's kind of a crazy one. Let's do this one. So this one is 2/3. And just for clarification, you're not obligated to use cancellation. So for this, so for multiplying fractions, you just do it however you want, as long as you get the right answer. So this one is 2/3 times 3/5 times 5/7 times 7/10. So as you could see, it's pretty much designed, this question, to be perfect for cancellation, because not only are there common factors on the top and the bottom, but there's directly common numbers on the top and the bottom. So you can cancel out whatever you can. So there's a 3 and a 3, goodbye to those. There's a 5 and a 5, goodbye. Goodbye to 7, goodbye to 7. Oh, and you can, so there's a 2 and a 10 left over. So just as if you had 2/10, you can reduce that a little bit as well. You can take a 2 out of there. So whenever you're taking just a factor out, rather than like scratching out numbers, you just go divide by 2, and then you just see what you get for each number. So 2 divided by 2 is just 1. So I can scratch that out. And just for clarity, I'll put a 1 right there because there's no other numbers on top. And then 10 divided by 2 is 5. So there you go. You do some cancellation, you take out some factors, and you could directly get to the answer of 1/5. And this is a good example of cancellation, because if you didn't do cancellation, it kind of sucks, because you would get, what's the original question? 2/3 times 3/5 times 5/7 times 7/10. So if you just did standard multiplication, you would get 210 over 1050. And then you would have to figure out what factor to take out of it, which is pretty easy in this case, because if you just compare it to the top number, you know you're going to end up with a 1 on top. So of course, the only way to end up with a 1 on top is to divide by 210. So that is presumably what you would take out of this, and then you would get 1 over 5. And there's actually another cool way of deducing what number you would hypothetically take out. You could just look at what you canceled. So you could look at the fact that you took out a 3 when we did cancellation. We took out a 5, we took out a 7, and then we took out a 2. And if you multiply those all together, all the factors that you removed, it should equal 210. So everything kind of comes full circle and balances out if you do everything properly. Let me just see that this does equal 210, and yes, it does. Let's see. Okay, so that's good for cancellation. And then for division, we'll do like 1 or 2. Oh, and there's even more, these are even more cancellation questions. So check those out. Okay, so let's do division, because like I've said before, this is one of the questions that people, it just seems to leave their brain for whatever reason. Although I guess the test will be online, so that's less of a worry than normal. But still, people will still get the wrong answer regardless. Let's do, is there any, I guess these are all the same. 1 over 2 divided by 1 over 3. So this is the one where you keep the first fraction the same, you change the sign to multiplication, and then you flip the second fraction upside down. You reciprocate it, as they say. And then you just do standard multiplication. So in this case, you'll get 3 over 2. And yeah, that's all you have to do. Oh, and if you do convert your answer to a mixed number, like in this case, this would be 1 and 1 over 2, right? Yeah, if you do write your answer as a mixed number, that's fine. It's pretty much equivalent to an improper fraction. Just make sure that your answer is reduced regardless, because we did do like a short lesson on the fact that just because it's a mixed number doesn't always mean that it's reduced. For example, you could have something like 5 and 2 over 4. And in that case, it's not technically reduced because the fraction part is not reduced. So just make sure that you're, even whether it's a mixed number or an improper fraction, make sure that you reduce it. In this case, you would just reduce the actual fraction part. You would just divide by 2, and we'd get 5 and 1 over 2. So that's, I think we're good for division. And now let's do a couple of adding. Oh, and then there are some decimal ones as well. Okay, let's do some adding questions. Everyone's favorite math questions, adding fractions. Any interesting ones? Oh, this one's kind of neat. Let's do 5 over 6 plus 13 over 15. Okay, so, and if anyone forgets how to do these ones, just remember it's the one where it requires a lot more work than multiplying fractions. That's how I remember it. I just think, okay, it's the one that has, least common denominator. You got to do a bunch of stuff, and that helps me remember the method for it, even if it's a generic way of remembering it. So in this case, what would be our least common denominator? Anyone? So a multiple of 6 and a multiple of 15, and the lowest number that is a multiple of both of them. Anyone at all?
90.
Sorry, say that again.
90.
Someone said, was that 19?
90.
Oh, 90. 90 would 90 work? It would work, but it's not the minimal number that you can use. So it is a multiple of both of
30.
them. Sorry?
30.
Yes, exactly, 30. So yeah, and for figuring out this one, I would use, again, just kind of my personal method, just because I think it's the best. And my method is you look at the sorry. You look at the largest number on the bottom, and I like to just go through multiples of that. And that kind of simplifies it a little bit. So you could just go 15, 30, 45, 60, etc. And then you just look at that list and you just pick the first one that works. 15 doesn't work because 15 is not a multiple of 6. On the other hand, for 30, 30 actually does work for both of them. It's a multiple of 15 and it's a multiple of 6. So let's do that. Okay, so to get 30 for the first one, we have to multiply it by 5. So times 5 times 5. And to get 30 for the next one, you got to multiply. So we multiply by 2, multiply by 2. And where I'm getting these numbers is I'm just trying to get 30 on the bottom for both of them. And then, of course, what you do on the bottom, you have to do on the top for each fraction. So this will be 25 over 30 plus 26 over 30, which is 51 over 30. And is that reducible? That's a tough one. Is 51 even, is that a prime number or, let's see, 51, maybe 17 goes into 51. I'm just curious now. 51. Oh yeah, okay, yeah. 17 times 3 is 51. Oh, good. So it is reducible. We can take a 3 out of this. Okay, for some reason it looked reducible. So divide by 3, and you get 17 over 10. So that one's harder to see. It was more or less just a guess. But yeah, so 17 over 10, you can't reduce that any further because 17 is a prime number. If you want, you could convert it to a mixed number, of course. Is that right? Yes. So that, of course, is adding fractions. Everyone practice that because a lot of the times people lose a lot of marks on the test on adding and subtracting fractions because like the other questions are out of like multiplication's out of 2, division is out of 3 marks, but addition is out of 4 marks. So, and then there's usually 2 addition questions, 2 subtraction questions. So a lot of the times people just won't fill out those questions, and that's 16 marks that they lose right there just from that one little topic. So practice the adding and subtracting fractions. And for this one, you could have also, so there's various methods for finding the least common denominator. For this one, you could have used the fancy, what's it called, prime factorization method, where you take each bottom number and you break them down into their factors. So 6 is 3 times 2, and those are, you can't go any further than that. 15 is 3 times 5. So you need the minimal string of numbers that has a 2 and a 3 and a 3 and a 5, but you don't have to repeat any of them. So the minimal string would be, so you need a 2, you need a 3, you need another 3, but you already got one, so don't worry about that. And you need a 5. So that's 2 times 3 times 5, which is 30, which is exactly what our least common denominator ended up being. So if you're stuck, you could always use the prime factorization method. It's a very elegant method and it always works, but I still like my method the best. I guess I can't really call it my method. I'm sure plenty of people use it. What else can I say about adding fractions? Does anyone have any questions that they're stuck on in regard to adding fractions? I guess everyone seems good today. Maybe everyone's tired because it's Friday. And why does it keep raining? It's so annoying. It's been raining for like 2 years. Not quite, but you know what I mean. What else? Let's do, oh, this is an interesting one. This one has 4 fractions. Someone said they agree. Good. Although I like thunderstorms. I find them relaxing, but when it's constantly raining, it's lame. Okay, next one is
all weekend.
What's that?
Supposed to rain all weekend.
Darn it. So 1/3 plus 1/4. And it sucks because I recently sold my car. So now it's like no car plus rain equals nothing to do. 1/3 plus 1/4 plus 1/5 plus 1/6. So with this one, it looks like I got lazy and I just decided just to do 3, 4, 5, 6. Oh, someone said they have to shovel and scoop the water off their boyfriend's boat cover every day. That's funny. I wish I had I was gonna say I wish I had a boat. Even a boyfriend with a boat. Boats are awesome. He's out of town. Let's see. Okay. Back to, sorry, we keep getting distracted. So for this one, we got 3, 4, 5, and 6. It would be kind of cool to do prime factorization for this one, because a lot of these are easy to factor. Let's do that. So 3, if you factor it, is just 3. It's already a prime number. 4 is 2 times 2. 5 is 5. And 6 is 2 times 3. So you need all those numbers, but you don't need to repeat them, and it'll be the minimal amount. So you need a 2 times 2, because that's specified right here. You need a 3, so let's do times 3. You need a 2 times 3, but we already got that, so goodbye to that, don't worry. And then the last one is a 5, we need a 5. So 2 times 2 times 3 times 5. That's 12 times 5, which is 60. 60, that seems to make sense. So that works for 3, that works for 4, it works for 5, and it works for 6. And nothing lower would work. The only thing that would hypothetically work might be 30, but that's not divisible by 4. So 60 is what we'll use. And to save time, I'll just alter the fractions right here. Okay, so 3, let's multiply that by 20. So 4 times what equals 60? That would be 15. 5 times what equals 60? That would be 12. And then 6 times what equals 60? That would be 6 times 10. So now we got 20 over 60 plus 15 over 60 plus 12 over 60 plus 10 over 60. So the answer is going to be, so it's going to be over 60. That's always the case. That's why I write that part first, since the bottom number always stays the same. And then 20 plus 15 plus 12 plus 10, that's beyond my abilities. So let's see, that is 57. And this looks like it doesn't reduce, because usually when the numbers are really close, it doesn't reduce. And it also looks like 57, I think, is a prime number, but I'm not 100% sure, but I'm pretty sure it's not reducible. So those were some good examples. Let's do one of subtraction. Oh, this one is, geez, this one's really easy. 4 over 7 minus 2 over 7. So for this one, don't overcomplicate it. It already has a common denominator, so you just subtract the 2 fractions and you'll get, so 4 minus 2 is 2, and the bottom number stays the same. So that one's definitely an easy one. Any other ones that are interesting? So those are basically the same. Let's do one more for this one. So 3 over 11 minus 1 over 6. So for this one, I'd also maybe recommend using the prime factorization method. Or you could just, use my method, go through multiples of 11. So it's like 11, 22, 33, 44, 55, 66. And of course, 66 works for 6. So 66 is going to be your LCD, as they say. Or if you want to use prime factorization, 11, if you factor it, is 11 because it's a prime number. 6, if you factor it, it's 2 times 3. So you're going to need this and you're going to need that. So in other words, it's just going to be 6 times 11. So that's one thing that's nice about prime factorization is sometimes you don't even have to write much down. You could just kind of think about it for a second, and a lot of times it automatically gives you the answer. So LCD is 66 in this case. So for the first one, let's multiply it by 6. And the next one, to get 66, we got to multiply it by 11. So sometimes it's just like reversing the numbers. Sometimes you multiply, like you got a 6 here, you got a 6 here, you got 11 here, you got 11 here. That happens sometimes, but as we've seen in other examples, it doesn't happen all the time. So this is 18 over 66 minus 11 over 66, which is 7 over 66. And that does not reduce because 7 is prime and 66 is not a factor of 7. Okay, so let's just quickly go through some decimal questions. I think there's only 2 questions for this. Oh, and then there's percentages as well. That's going to be on there. But we can always, we're running out of time. We could always go over them on whenever. Well, plus we're taking up the assignment on Monday, so that's pretty much a review in itself. So one thing I want to mention for decimals is another question, probably the #1 question that everyone just always forgets. It was converting from fractions to, actually converting from decimals to fractions. So does anyone remember off the top of their head the method for this one? Like if we had 0.113, does anyone remember the general method for doing these ones? And Buddy, you're free to answer as well. Buddy's hanging off my back somewhere.
Don't you
Anyone
just
remember?
put the 3 digits, like the 113, over 100?
Yes, in this case, it would be 1,000 because there's 3 digits. So, but what you're saying is, yeah. So for this one, you count 1 digit, 2 digit, 3 digits, and that is what you use for the bottom number. You use 1 with 3 zeros. And then for the top, you just use just the actual digits of the number. You just write it as a whole number. So in this case, you'd get 113 over 1,000. So again, when you look at these ones, they take 2 seconds. They're all the same, and that's probably why everyone forgets how to do them. So everyone practice these. Although I keep forgetting that this is like open book and open textbook, so I guess it's less of an issue. Although I have read articles that have said that when you give students formula sheets, they do worse on tests. And when you give people open book tests, they do worse as well, because in those circumstances, people study less. 0.00.
New box.
Sorry?
New box.
I think someone accidentally unmuted their mic. Hold on. Just mute everyone. Someone said, so our test is open book. Well, I mean, the test is online, so it's not like I'm sending it to you and then you'll fill it out and send it back. So it's not like I can stop anyone from using their textbook or your notes or whatnot. So yeah, it's essentially open book. Where were we? So there was that. Let's just finish that one example and then we'll call it a Friday. Once, twice, 3, 4 decimal places in this case. So at the bottom, write a 1 with 1, 2, 3, 4 zeros. And then on top, just write a 3. You don't have to write like 0003 because that's just the same thing as 3. So just write the actual number. And then final last thing for today is just rounding decimals, which will also be on the test, which some people do have a lot of trouble with, which is another one where if you don't know the method or if you do it incorrectly, you lose potentially a significant amount of marks. So let's do rounding to the tenths, or you could also state that as rounding to the first decimal place. Either way of stating it is equivalent. So round to the first decimal place for 4.356. So remember for this one, if you're rounding to the first, what you do is, so there's the 3 right here, but what you really want to look at is the 5, and that'll tell you what to do. So you always look 1 digit to the right of the number that you're rounding to. So remember, 5 and above means round up, 4 and below means round down. So for this one, you round up and you'll end up with 4.4. So yeah, rounding up, you always drop the appropriate digits and increase the immediate one to the left by 1. Everything else stays the same. Sometimes people do weird things where they'll appropriately round it, but then they'll take the 4 and they'll like round it down to 0 and they'll claim that the answer is 0.4 or something like that. Don't do stuff like that. Just change the appropriate digits. Most of them end up staying the same. At the very least, the whole number part will stay the same. And now let's do to the thousandths. Thousandths. Also known as to the third decimal place. 109.3222. Okay, third decimal place is this one. So we look at this, and of course we round down. So that's the easiest case. You just get rid of that digit and everything else remains the same. Another weird thing that people will do is they'll take every digit and they'll round it down, or they'll decrease it by 1. Don't do weird stuff like that. Again, just, yeah, practice the examples and learn the format, and this ends up being not too bad. Okay, so we don't have time for percentage, but we'll just cover that when we take up the assignment. Okay, let's stop sharing, and I'll put the video on and I'll show Buddy for one last time. See, he's somewhere. Oh, he's somewhere there. There he is. Don't fall, Buddy. I don't want to grab your head. Come on. Oh, hold on. There you go. There's Buddy hanging out with me. Buddy's so loyal. So does anyone have any questions? So everyone seems pretty good. Okay, I think I got everyone on the attendance. So I guess that's it. Let's pause the recording.